So we can do a problem that would be use all three, or really not all three. Really, what you're going to do is, if there's anything, the most complicated problem I could ever think of would be I give you a reaction that occurs that produces a certain amount of gas that's displaced by water.
Is
That
there one like that that we can?
I'm not thinking of one on the top of my head. There will be a water displacement one on the test, but it would be more like water displacement and the combined gas law, or Gay-Lussac's law or something like that.
Okay.
So it would be using Dalton's partial pressure and then using that partial pressure to find what the new pressure would be at a different temperature. Does that make sense?
Yes.
And then another one, I would say probably the most difficult one we could do is, let me see if I could pull up. It's this one here. This is probably the most difficult problem. I like problems like these. Maybe no one else does, but this is, I think I like them because they do make you think. Um, and so this one is phosphine is the phosphorus analogous analog to ammonia. It can be produced by reaction between calcium phosphide and water according to the following equation. Now, so this is stoichiometry here initially. And what we're given is the grams of this calcium phosphide compound. Um, we're trying to find the volume. We have the temperature and we have the pressure. And where we need to go is to go from calcium uh, phosphide over here to phosphine. So the way that problem is going to be set up is similar to what the other one was. Um, so you have,
Just like convert it first.
right, you have to find, so here's the thing, you want to get, since we're not with gases, most of the things that we find are in moles, not in grams. So if you're given grams, the idea is go from grams to moles, and to make sure that if the moles that you get, and if you're dealing with gases, that you're actually in a gas and the gas that is asked for, um, if that makes sense.
Hmm.
So you want to go from 8.46 grams of calcium phosphide to phosphine.
Would it be to liters of phosphine?
Well, here's the thing. If to get to liters of phosphine, see, this is the interesting thing. See, now it's not at STP. So the volume is going to be different.
Oh,
And what you do have, you could get to the volume of it, what it would be at STP. The volume of phosphine at STP, and then go from them relate it back somehow to the volume of but the see, the thing is the pressures change too. So you're not at standard temperature and pressure. The temperature is different, the pressure is different because the pressure is a little bit higher than STP, and same thing with the temperature. And when you mess with one of them, they kind of offset, they mess around with the other variables.
so you can only use the 22.4 conversion if it's at STP.
Correct. So
Okay.
that would have been a very easy one, but this one requires you to get, well, first we need to get to moles of,
pH 3.
yeah, pH 3 of phosphine. So you have 8.46 grams of that. And then if I go to my periodic table, let's see, C3P2. Okay. So 40.08 times 3 plus 30.97 times 2. Okay, I got 182.18.
That's what I got.
Okay. So 182 0.18 grams of this to 1 mole. Normally, I would write out the compound, but because it's going to working with my finger here.
Wait, is this problem using Pivner because it's like
We'll be
amount
using
of moles?
Pivner.
Okay, that
Exactly.
makes more sense
So,
than what I was thinking.
so the thing is you kind of have to think what variables you have and what it's really saying. Say we're not really changing any sort of temperature or relationship. It is at a particular temperature and a particular pressure. So you could just use Pivner, but you need the number of moles, which we can actually get. So if for every 1 mole of that, I get 2 moles of pH3. All right, that's going to be our N. Your R is going to be different. It's 8.314 liters, kilopascals, moles Kelvin, over moles Kelvin. Okay. Your P is this in kilopascals. Your temperature is going to be 291 Kelvin. So you can multiply all these three things together and then divide by 102.4 kilopascals.
I got 2.19 liters.
Let's see. Okay. 2.19 liters of phosphine.
Okay, I think it makes more sense. At first, I thought I was using like the combined gas law, and that's why I thought I needed to convert it to liters using the 22.4. But then,
Here's the thing about the combined gas law or any of the gas laws is that they're set up as relationships. So that means I'm changing something. If you notice in the equation, it's just said this is measured at this. However, um, I could just take that problem and say, uh, what volume will it occupy at a totally different temperature if pressure is kept the same? Does that make sense?
Mm-hmm.
So you could have gotten this new volume and I'm going to keep temperature the same, or I'm going to say, here's a new temperature and a new pressure. What volume will the gas occupy? Then you would use the new gas law or the combined gas law. So you found this volume, and then what you would do is if I said, let's find another volume um, uh, at STP or whatever, then you would change the temperature, you would change the pressure, you have a new amount. And so basically, the nice thing about STP is that you would just take those moles and then multiply it by 22.4. That's the easiest thing. But if I just picked a different temperature and pressure, you you would just take the pressure of the initial, the temperature of the initial, and the volume that you solved for, and then solve for the new volume at those new temperatures and pressures using the combined gas law.
Okay, so the combined gas law is like something changed, kind of.
Correct. Any of the gas laws. So it's like I have a gas. It's at this pressure and at this temperature, and I change it to have a new pressure. What is the new volume or new temperature? So it's a relationship, but something has to be kept the same. So like Boyle's law, temperature is the same. Charles' law, uh, pressure is the same. Gay-Lussac's law, um, volume is not changing. And then the combined gas law is a combination of all three, whereas like you're not holding any of those in the same at all. They're all variables. And the only thing that's really say, being the same is the amount. So it's like if I had a balloon of gas that's the same amount and I squeeze the balloon, increases the pressure, but I'm also going to heat up the gas in the balloon as somehow. So I'm changing the temperature, I'm changing the volume, but I'm also therefore changing the pressure. Does that kind of make sense?
Yes, that makes sense.
So like for this, since it's not changing at all, you can just use Pivnert.
I think I understand it more now. I don't know what I was confused on, but I think I'm more confident in it now.
I think I think everyone is very much capable of like doing these problems. I think just sometimes when we see it for the first time, we have a tendency to kind of like I've never seen this before and kind of clam up if that makes sense.
Yes.
So it's like sometimes we just have to try and just see what works. The nice thing is like if you're given grams of anything, um,
You
then
can convert it to moles.
yeah, it's like we need to get moles. And here's the other thing: it's like, well, I Margaret was she wanted to know about density. And here's the interesting thing: is like if you find the moles of a gas, and then I could just say, well, tell me what the density is. You could just take the density if like especially if it gave you a volume and the gas you already have the moles, you would just convert the moles to grams of the gas and then divide it by the volume and that would be your density.
Oh, okay. Yeah, that makes sense. What's density measured in? Like, what's like the unit for density?
The density is has different units. Anything that has
Could it be like grams per liters?
it can be grams per liter, it can be grams per cubic centimeter, grams per cubic decimeter, any of
Will
those.
will we need to know like the conversion factors for like decimeter to liter and like
I would say it. I if anything, if I give you something in cubic decimeters, it's probably going to be something where, for example, like with Charles's law, is that your answer will be in cubic decimeters too. So it does not matter. You won't have to do conversions for that. However, I do think it's good to know that 1 cubic decimeter is equal to 1 liter.
okay.
Um, like that's a good one to know. Mostly, probably what I may do is like transfer from liters to milliliters or something like that.
And then that's 1,000 milliliters in 1 liter.
Correct.
Are there any like on our quiz we had some questions that were like describe something like in like words, like how the kinetic molecular theory like
Yeah.
attaches?
Let me